We're going to look at perpendiculars in space. We are going to define what perpendicular figures look like in space, and then we're going to look at some theorems that involve perpendiculars in space. So perpendicular planes are two planes that form a right dihedral angle. So that means that the angles are 90 degrees. Here are two perpendicular planes, and then notice how they form right dihedral angles. So angle DABE is a right dihedral angle. So a line perpendicular to a plane is a line that intersects the plane and is perpendicular to every line in the plane that passes through the point of intersection. Here's a line that's perpendicular to the plane, which means that it's at 90 degrees. Okay, which means that at any line that goes through that plane is going to be 90 degrees point. So a perpendicular bisecting plane of a segment is a plane that bisects that segment is perpendicular to the line containing the segment. So we looked at a perpendicular line through a plane. Now we're going to look at a perpendicular plane through a plane. Here's a plane, and notice how this distance x is the same as this distance x, and it's going to be at 90 degrees. So we have a theorem that says a line perpendicular to two intersecting lines in a plane is perpendicular to the plane containing them. So that means it's kind of like the opposite of theorem 10.1. So this is saying the other theorem says that if a line is perpendicular, then every line on that plane is perpendicular to it. Then this one is saying that if you have a line and it is perpendicular to two lines in the plane, then it's also perpendicular to the plane. So line L, and we're going to say if line L is perpendicular to line M and line N, therefore we can say that line L is perpendicular to plane P at point A. Alright, next theorem says that if a plane contains a line perpendicular to another plane, then the planes are perpendicular. So that means that if the line is perpendicular to another plane, then those planes have to be perpendicular. So here we go. We have a line CD, and it's perpendicular. Next theorem, if intersecting planes are each perpendicular to a third plane, then the line of intersection of the first two is perpendicular to the third plane. If the line AB is perpendicular to a plane P at B, and segment BC is congruent to segment BD in plane P, then AC is congruent to AD. So the measurements are going to be the same. So here's an example of that. So that means, so again, it said that this was congruent to this. So therefore, next theorem. Every point in the perpendicular bisecting plane of segment AB is equivalent from A and B. The next theorem, it says that the perpendicular is the shortest segment from a point to a plane. So let's look at some questions. It says that two planes are perpendicular to the same plane are parallel. And is that true or false? So again, you're looking at two planes, and both of those planes are going to be perpendicular, so they're going to meet at 90-degree angles to another plane, to a third plane. So here's one plane, and it's perpendicular, and here's another plane, and it's perpendicular. So we would say that's false, because the planes, as you can see, are perpendicular to this plane, but they're not parallel, they're actually intersecting each other. So that would be a false statement. Next statement, it says two lines perpendicular to the same plane are parallel. So these two lines are perpendicular to the same plane, and look how they are parallel. That's the only way that they could both be going at 90 degrees. So this would be true. So this is different. So two planes that are perpendicular to the same plane do not have to be parallel, but two lines that are perpendicular to the same plane are parallel. All right, this is our last statement we're going to look at. It says that two planes perpendicular to the same line are parallel. So let's think about the image. You've got two planes that are perpendicular to the same line. So that means that they are going at 90 degrees, intersecting that line at 90 degrees. Okay, so here is our line, and here are the two planes. So the only way for them to go at 90 degrees is if they are parallel. All right, that's all for this video about perpendiculars in space.